All right, here we are. We have the example one problem, and we want to find the regression equation for the data on the population of a state and the number of professional sports teams in that state. Give it on page 236. We have listed below, and we want to know how many sports teams are predicted for Indiana, whose population is approximately 6.5 million. Okay, so the first step is to find the regression equation. And we're going to go ahead and do that using Desmos. Let's go ahead and do that. And I have Desmos right here. Okay, so first thing to point out, once you go to the link for Desmos, linear regression Desmos link provided on the slide, that you'll have this set of data here. You'll want to enter in the data, and I'll go ahead and show you how to do this. So the first data point you'll notice is for population in millions. For Arizona, you'll see 6.4. So you'll want to just put in 6.4 here. And you'll just go down the list and enter in all the X values. And 5 and 18.8. And just go down the list. And I'm going to enter in all the X values really quickly. One moment. I wanted to point out, after you get to the bottom of the first column, which was the 10 value, which was for Michigan, you should go up to Minnesota on the next half of the table. You'll see 5.3. So that's your next X value. Just wanted to point that out really quickly, so you'll enter that in. So, anyways, one moment. All right, I finished inputting all the X values, the population values, and now I'm going to go over to the number of teams. That will be your Y values. So we'll have 5, 16, 4, 9, 6, 3, 4, 5, 3, 9, 3, 7, 7, and 10. Okay, so there we go. And after you enter it in, it'll continually update, and you'll notice that your plot will also update. Now, if you're trying to graph this, the graph is here. Now, the scaling of the graph, if you're working on your homework, you may notice that it's a little bit different. You have the ability to move this around all you want. So you can zoom out a bit, zoom in a little bit, move it around, and eventually you'll see the option that fits your graph the best. So anyways, and then you have your regression equation is actually your M and B right here. You'll see Y1 and then this little tilde sign, MX1 plus B. So and so I'll go ahead and copy this over to these values. I'll go ahead and copy these over to the page that I'm writing on. One moment. All right, I copied over the general form y equals mx plus b, and then the m and the b value we found from Desmos. And now we just want to substitute this into our equation. So we have y equals m. M is defined, is calculated to be 0.37944 x plus, and then 1.37485. Okay, so that's our regression equation, and that's what we're looking for. Now we can use that information to determine how many sports teams are predicted for Indiana, whose population is 6.5 million. So the population is in millions. So 6.5 million tells us that X is equal to 6.5, because that was our X value. So now we can just plug in X equals 6.5 into this equation. And then substitute 6.5, and we're going to add 1.37485 485. And this calculation you can do pretty easily with your calculator, and you'll end up getting approximately equal to 3.84. And since sports teams, you can't have a decimal amount, so we're going to, as mentioned, we're going to round to the nearest whole number, which gives us 4 as our solution. So 4 sports teams. And there we go. So there's our regression equation. We predicted a value using the regression equation. And I'm going to go back to the Desmos and point out some other information. Our R value, see there's what's known as the correlation coefficient. That's our R value. That's a very strong R value. That if it's really close to 1, or if it was a negative slope, it would be really close to -1. As you can see, this is pretty close to 1. It has a positive slope. It's very close to 1. So that's a strong correlation. That's telling you that these data values fit this regression line very well. It's a very good correlation. Just to point that out. And so anyways, that's about it. You have this R squared value. That's called, you won't need to know this, but it's called the coefficient of determination. You'll see that if you take a statistics course. But anyways, let me know if you have any concerns about this process. I'll be more than happy to help.